Hi everyone, in this video I'm going to solve A-Levels Mathematics Paper 1, Pure Maths 1 in a session May-June 2022, Paper 1-3. So let's start with the first question. Question number 1, the coefficient of x cube in the expansion of this is 144. Find the possible values of constant p. So let me expand this and find out the coefficient of x cube. So we have p plus 1 over px, its power is 4, p power 4 plus 4c1, p power is 3, x over p plus 4c2, p square, x over p square plus 4c3, p power 1, x over 3, p whole cube. So this is a term having coefficient x cube. Okay, so we have given that the coefficient of x cube in this expansion is 144. So we can say that 4c3 p power 1 x cube over p cube, what is equals to 4c3. 4c3 is 4, and we can simplify the p with p square, 4x cube over p square. Right, now it's comparing coefficients. We know that this coefficient is equals to 144x cube. So when I compare the coefficient, we have 4 over p square is 144. Okay, let me solve for the p value. So from here, 4 over 144 is equals to p square. 4 divides 144, this is 1 over 36. So p square is 1 out of 36. And what is p? P equals to plus minus 1 over square root of 36, which is 6. So p value, the possible values of constant p is plus minus 1 by 6. Question number 2. The diagram shows the part of the curve with the equation y equals to p sine q theta plus r, where p, q and r are constants. Part A, state the value of p. So what is p over here? P is the amplitude basically, right? So we have to find the amplitude by using the formula maximum minus minimum divided by 2. So the maximum point of the curve is 1 and the minimum point of the curve is minus 5, right? P is amplitude, which is max minus min divided by 2. Okay, so the maximum point is 1 minus the minimum point is minus 5 divided by 2. So 1 plus 5 is 6 divided by 2, which is equals to 3. So p value is 3. Right, now for part B, state the value of q. So what is q over here? So we can get the value of q by using the information of period, right? Period is 1 complete cycle. So if I start from this point when x is 0, so 1 complete cycle ends at 4 pi, 1 complete cycle, right? Okay, so we have a period is 4 pi. So what is q? Q is in terms of radians 2 pi over period, which is 2 pi over 4 pi, which is 1 by 2. So q value is 1 by 2. Now for part C, state the value of r. So r is the equation of x's. So equation of x's has a formula r, which is maximum plus minimum divided by 2. Since we know the maximum is 1 plus the minimum is minus 5 divided by 2. This is negative 4 by 2, which is equals to minus 2. So we can say the r value or equation of x's is negative 2. Question number 3. An arithmetic progression has a first term 4 and common difference d. The sum of the first n terms of the progression is 5863. Part A show that this term equals to this. Okay, we have given Sn. So Sn has a formula n over 2 into 2a plus n minus 1 into d. Right. So first sum of first n terms is given 5863. This is equals to n divided by 2. 2 times of 4 plus n minus 1 into d. Right. Now we have to simplify this. We can say 5863 equals to 2 is cancelled with 2, 4n plus this is n minus 1 into d times n by 2. Right, we have to find n minus 1 into d and shifting all the terms on the other side. Right. Okay, so we can say 5863 minus 4n, right, and then times by n by 2. This is equals to n minus 1 into d. Okay, let me simplify this further. If I can do the remaining steps over here, we can say n minus 1 into d, n minus 1 into d. This would be equal, sorry, when we do the reciprocal of n by 2, this is 2 by n, 2 over n, not n by 2. Okay, so when we have to times 5863 by 2, we have 5863 times 2, which is 11726. 11726 divided by n, and 4 times 2 is negative 8 and is cancelled with n, so minus 8. So n minus 1 into d would be equals to 11726 over n minus 8. Right. Now moving to part B, given that the nth term is 139, find the value of n, and d give the value of d as a fraction. Okay, since we have given the nth term, which arithmetic progression nth term is a plus n minus 1 into d, which is 139, and we know that a value is 4, so 4 plus n minus 1 into d, this is equals to 139. Or we can say that n minus 1 into d, this would be equals to 139 minus 4. Okay, 139 minus 4, which is 135. This is my equation static. Let me substitute into this information. So we can say that n minus 1 into d, this is 11726 over n minus 8. Right. So this is 135. So 135 equals to 11726 over n minus 8. So here we can solve for n. Right. Okay. So we can say 135 plus 8. Right, this is 11726 over n, right? So 135 plus 8, sorry, 135 plus 8 is 143. So cross multiplying, what is n? N is 11726 over 143. 11726 divides 143, which is 82. So n is equals to 82. The number of terms are 82. And now let me find the value for d. Right, by substituting into the equation star, we can solve for d. So from here we can say that 82 minus 1 times d is 135. So d would be equals to 135 over 81. 82 minus 1 is 81. Yes, 135 divides 81, which is 5 by 3. So d must be in fraction. This said, giving the value of d as a fraction. So the d value is 5 over 3, and then value is 82. Question number 4, part A. The curve with equation this is translated minus 1, 3. Minus 1 is the horizontal translation, and 3 is the vertical translation. Find the equation of translated curve giving your answer in the form of y equals to ax square plus bx plus c. Okay, so horizontal translation is -1, so 1 unit to the left, and vertical translation is 3 units up. So we can say y is equals to x plus 1, adding 1 in your x value, plus 2 times of x plus 1 minus 5, right? And 3 is the vertical translation, just adding 3 outside. Let me simplify this. Y equals to x square plus 2x plus 1 plus 2x plus 2 minus 5 plus 3. So here y would be equals to x square plus 4x, and you have 1 plus 2 would be 3. 3 plus 3 is 6, and 6 minus 5 is plus 1. So this is the equation of translated curve. In the form of y equals to ax square plus bx plus c, right? Now moving to part B, the curve with the equation y equals to 2x square plus 2x minus 5 is transformed to the curve with the equation this. Describe fully the single transformation that has been applied. So if I do the comparison of two curves, this and this, as you can see, we have y is either transformed. One is y equals to 2x whole square plus 2 times of 2x and minus 5. So if I compare with the given one, which is y equals to x square plus 2x minus 5, right? So it means with 2x, we have to multiply by 2. So means x are multiplying by 2, right? So when x is multiplied by 2, it means we have a horizontal stretch by a factor of 1 by 2. Yes. Horizontal stretch by a factor of 1 by 2. Because as you can see, x square is replaced with 2x square. Right, so x are multiplying by 2. Here again x is multiplying by 2. So means we have a horizontal stretch by a factor of 1 by 2. Question number 5, part A, solve the equation. So to solve this equation, we have to multiply throughout the equation by square root of y. Multiplying both sides by square root of y. So 6 square root of y times square root of y is just y, plus 2 minus 7 square root of y, which is equals to 0. Now let me suppose, let's suppose that u is equals to square root of y, if I can say. U is equals to square root of y. And what is y? Y equals to u square. Right. If I substitute over here 6u square minus 7u plus 2, this is equals to 0. Right. Okay, let me factorize this. 6 times 2 is 12. And 4 times 3 is 12. And minus 4 minus 3 is minus 7. Right. Minus 4 and minus 3. So taking 2u common, we have 2 times 3 u square minus 2, and sorry, u, and negative 1 is common, 3u minus 2 equals to 0, equals to 0, right? So the factors are 3u minus 2 and 2u minus 1 equals to 0. From here we have u is equals to 2 by 3 and u is equals to 1 by 2. Right. Substituted back, we have u is square root of y. So we can say square root of y equals to 2 by 3, or square root of y is equals to 1 by 2. right? And to solve for y, we have to do scaling on both sides. 2 square is 4, 3 square is 9, y is 1 square is 1, and 2 square is 4. So 1 by 4 and 4 by 9 are the two solutions, right? Now for part B, hence solve the equation. You have to solve this equation equals to 0 for x is between 0 to 360 degree. As you can see, we have 6 square root of y plus 2 over square root of y minus 7, and over here we have square root of y is replaced with square root of tangent x. So basically we have to, let us suppose that y is replacing with tan x. Right, now we have two values for y. We can easily solve for the two solutions, right? So from here we can say tan x is equals to 4 by 9, or we can say tan x is 1 by 4. These are the two solutions we got from the first A part. Okay, now both equation tangent is positive, so we can say x is equals to tangent inverse of 4 by 9. And from here x is equals to tangent inverse of 1 by 4. We have to do in degrees since my domain is in degrees. Okay, so my calculator is in degrees, yes. Tangent inverse 4 by 9. X is equals to 23.9. We can say 24 degrees. And tangent inverse of 1 by 4. 14.03, or just 14, we can say x is equals to 14 degrees. Okay, now tangent is positive by using the cast rule in first and third quadrant, and for the third, this is for the first quadrant, 14 degree and 24 degrees belongs to the first quadrant between 0 to 90. Now for the third quadrant we have to do 180 plus the theta values, right? So if we can do 180 plus 24, which is 204, so here x is equals to 204 degrees, and if I can do 180 plus 14, which is 194 degrees, so x is equals to 194. So these are the four solutions of the equation between the domain 0 to 360 degree. Question number 6, the function f is defined by f of x is a quadratic function for x is less than 3. Part A, express f of x as 2 times x plus a whole square plus b. Okay, so if I can take 2x square minus 16x plus 23. This is my f of x. So let me take 2 common, x square from the first and the second term, and 2 times 8 is 16x plus 23 is outside, right? Now next step, 2 is outside, we have x square minus 8x. Now taking the coefficient of x, which is negative 8, divided by 2 and take its whole square. So 2 times 4 is 8 and 4 square would be 16. So we have to add 16 and subtract 16 inside the bracket, and plus 23 is outside. Now 2, combine the squares, x square minus 8x plus 16 plus 23 and minus 2 times of 16, shifting this negative 16 outside, right? Now we have 2 into x minus 4 whole square. If we complete the square, x square and 4 square, and 2 times of 16 is 2 times 16, and 23 minus answer is negative of 9. So this is converted into the form of 2 times x plus a whole square plus b. So a value is negative 4 and the b value is negative of 9. Now for part B, find the range of the function f of x. So f of x we have given, which is 2x square minus 16x plus 23 for x is less than 3. All the values which are less than 3. Okay, so since the domain is given, so let me find what is function value at 3. The values which are less than 3, you can take 2, 1, 0, minus 1, minus 2 up to negative infinity. Okay, so 2 times 3 square minus 16 times 3 plus 23. Let me simplify this. So 2 times 3 square is 9 minus 16 times 3 and plus 23, which is negative 7. So the function value at 3 is negative 7, and the function value at negative infinity is also infinity. You will get infinity, right? So we can say the range. From here we can easily analyze the range. of f of x is all the values that are less than minus 7. Sorry, from if you put my negative infinity, so negative infinity scale, you have positive infinity, negative times negative is positive infinity, so answer is positive infinity. So minus 7 to infinity, the greater than minus 7. We are not including equals to minus 7 because here the domain is not equals to 3. So the range is all the values that are greater than negative 7. Now for part C, find an expression for f inverse of x. We have given y equals to f of x, which is 2x square minus 16x plus 23. Now switching the variables, we can say x would be equals to 2y square minus 16y and plus 23. Or we can do it in a better way. We know that f of x is also equals to 2 times of x minus 4 whole square minus 9 from a part. We have already converted this into this form, right? Okay, then we can say this is your y. Now we can switch the variables. We can say x would be equals to 2 times of y minus 4 whole square minus 9. So x plus 9 divided by 2, this is y minus 4 whole square. So to get rid of square, we can do square root on both sides. We can say y minus 4, this is square root of x plus 9 divides 2 with a plus minus sign. So what is y? Y equals to 4 plus minus square root of x plus 9 divided by 2. All right. Now, as we know that the domain we have given for the domain of f is the range of f inverse, right? Okay, and the range of the function should be the domain of f inverse. The range of the function is all the values that are greater than minus 7. So that is my domain for f of x. So that is why we are taking it negative, not the positive one, right? Now for the next part, the function g is defined by g of x is a linear function, 2x plus 4 for x is less than minus 1. Part D, find and simplify an expression for f g of x. F and g of x is 2x plus 4, which is equals to f of x is 2 times or we can say 2 times, if we can substitute in this form. This is better. It's just a 2-mark question. So let me substitute x value over here. So x is 2x plus 4 minus 4 whole square minus 9, right? So simplify this. So 2 times 2x square minus 9. This is 2 times 4x square minus 9, or the only simplified form we can say 2 times 4 is 8x minus 9, 8x square minus 9. This is a simplified form for f composition g of x. Question number 7. The diagram shows the circle with the equation. This is a circle. We have given the equation of a circle and with the center C. So C is the center of a circle, which is 2 minus 4. Right. The point B has a coordinate 0, 2, x is 0, y is 2, and the line segment B to C intersect the circle at point P. Now for part A, find the equation of BC. So this is a straight line, as we need to find the equation of line, which is the form y equals to mx plus c. C is the y-intercept, which is equals to 2. So y equals to mx plus 2. So let me find out the slope. We have given the point B and C. So we can find out the m value, which is the slope. And it has a formula y2 minus y1 over x2 minus x1. So we have a coordinate for B is 0, 2. And for C we have 2 minus 4. Right, let me use these coordinates to find out the slope. So we have y2 minus y1 minus 4 minus 2 over x2 minus x1. We have 2 minus 0, which is negative 6 over 2, which is equals to negative of 3. 2 times 3 is 6. Yes, negative 3 is the slope. So we can say that equation of line BC is y equals to mx plus c, which is y equals to minus 3x plus 2. Right. Now for part B, hence find the coordinates of P, giving your answer in the exact form. Okay, so what is P? P is the point of intersection of the line and the circle, right? So we have given the equation of circle. Let me write down the circle, which is x minus 2 whole square plus y plus 4 whole square equals to 20. And the equation of line, we have given that y is equals to minus 3x plus 2. So let me substitute this y value over here and solving for x first. So we have x minus 2 whole square plus y value is minus 3x plus 2 plus 4 whole square equals to 20. Okay, so x minus 2 whole square plus minus 3x plus 6 whole square equals to 20. Right, for the simplification we can say x minus 2 whole square, if I can take minus 2 common, we have minus 3 is common, x and 3 times 2 is 6 minus 2 whole square equals to 20. So we have x minus 2 whole square plus minus 3, this is negative 3, sorry, 3 square is 9 into x minus 2 whole square equals to 20. So we have 10 x minus 2 whole square equals to 20. So x minus 2 whole square equals to 2. 10 divides 20 divides 10 is just 2. So taking square root on both sides, so x minus 2 equals to plus minus square root of 2. So what is x? X equals to 2 plus minus square root of 2. So we have to use which x coordinate. So as you can see, when the point of intersection of line on curve, x is positive and y value is also positive. So we have to consider only the positive root. So x is equals to 2 plus square root of 2. Let me check. So 2 plus square root of 2. This is x would be equals to 3.4. Okay, so as you can see, this point of intersection, x is over here, this is the x value, and here the x value is 2, you can see, and the y value is negative 4. So it should be less than 2, not more than 2, right? So we have to check at minus 2, sorry, minus 2, which is 0.5. Yes, we can take minus 1. 0.585, 586, you can say. Okay, now let me find the y coordinate. So for y coordinate, we have to substitute into the equation. Y equals to minus 3 times x, 2 minus square root of 2 plus 2, right? So y would be equals to minus 6 plus 3 square root of 2 plus 2. Y would be equals to minus 4 plus 3 square root of 2, right? So we can say the coordinates of P, we can write down the coordinates of P are x, y coordinate. X coordinate is 2 minus square root of 2 and minus 4 plus 3 square root of 2, right? Question number 8, the diagram shows the curve with the equation. We have given the equation of a curve. The line y equals to 5 intersects the curve at a point A and B. Part A, find the equation of tangent to the curve at point A. So equation of tangent to the curve is basically equals to y minus y naught is equals to m, the gradient, into x minus x naught. So we have given the point x naught, y naught, which is equals to, we have x naught and y naught is the point A, which is 1, 5. We have to find the gradient at x is equals to 1. So what is m? M is dy over dx. So let me solve for dy over dx. So differentiate this. First we have to use a power base, power minus 1, plus 4 is as it is, times the power the base function and the power -1, which is -1 by 2, -1, -3 by 2. 2 times 2 makes 4, which is 1 by 2 square root of x minus 2 over x power 3 by 2. Right, now at x is equals to 1, we have to find the gradient dy over dx. At x is equals to 1, we have 1 by 2 minus 2. Okay, so 1 by 2 minus 2, which is minus 3 by 2 is the gradient. Right, now we can say that the equation of tangent is we have y minus y naught equals to m into x minus x naught. This is the equation of tangent at a point A. Now for part B, calculate the area of the shaded region. Okay, so look at this shaded region. The shaded region is between the curve and the line. So this curve and the line y equals to 5 between the point A and B. So x coordinates are 1 to 16, right? So basically we have to integrate since the curve, the line is at the top and the curve is at the bottom in the shaded area. So we have to find the area of a line minus area of a curve. Area under the line and area under the curve. Yes. Okay. So we can say that the shaded area is integration of a line from 1 to 16. Line is 5 dx minus integration 1 to 16 of a curve, which is x power 1 by 2 plus 4 x power minus 1 by 2 with respect to dx. So let me simplify. The integration of 5 is 5x square over 2. 1 to 16 is the limits minus the integration is x power n plus 1. 1 by 2 plus 1 is 3 by 2 over 3 by 2 plus 4 x power minus 1 by 2 plus 1 is 1 by 2 over 1 by 2, 1 to 16, right? So we have 5 by 2 x square 1 to 16 minus, so this is 3 by 2 changes to 2 by 3, 2 by 3 x power 3 by 2 plus 4 divide answer, which is 8 x power 1 by 2 1 to 16, right? Now let me substitute the limits. We have 5 by 2 16 square minus 1 square minus 2 by 3. We have to do 16 power 3 by 2 plus 8 16 power 1 by 2 minus 2 by 3. 1 power 3 by 2 is just 1 and minus 8. 1 power 1 by 2 is also 1, right? Further simplification, we have 5 by 2 16 square minus 1 square 255 minus 16 power 3 by 2 64 times 2 divides 3 128 over 3. Okay, square root of 16 is 4 times 8, which is 32. Minus 2 by 3 and minus 8. Okay, for this simplification, we have 255 times 5 divided by 2 is 1275 over 2 minus, simplify this, we have 128 over 3 plus 32 minus 2 by 3 minus 8, 66. Sorry, I did the mistake here. The integration of 5 is just 5x. And then we apply the limit upper minus lower. So this would be 15, and 5 times 15 is 75, right? And to find the shaded area, we have to do 75 minus 66, which is equals to 9. So we can say that the shaded area is 9 square units. Question number 9. The diagram shows a triangle ABC with AB and BC is 6 centimeters. So this is an isosceles triangle, and angle ABC is 1.8 radians. The arc CD is the part of a circle with the center A. So means A to D and A to C is same, right? Okay, ABD is a straight line. Now for part A, find the parameter of the shaded region. So the shaded region parameter is B to C, which is 6 centimeter. We have to find BD and CD. Okay, so to find the parameter of the shaded region, we have to find the sum of BC, which is 6 centimeter, BD and CD. Okay, so CD is the arc of a circle with the center A. So we have to find the theta over here, and then radius times theta, and we have to find the radius AC and AD, sorry. Okay, so what we have to do, the first step, we have to this side and this side. Let me find what is AC by using law of cosine. Yes, by using law of cosine, let me find the side AC whole square is equals to 6 square plus 6 square minus 2 times 6 times 6 cos of 1.8. Right. Okay, so AC square, this would be equals to 6 square is 36 plus 36. Okay, cos 1.8 in radians times 6 times 6 times minus 2, or 16.36 plus 16.36. Add 36, and then doing a square root, we have AC, which is equals to 9.4 centimeter, right? So this is 9.4. So AC is 9.4, AD is also 9.4. So from here, A to D is the sum of AB plus BD, and BD is the shaded one, right? So AD, we have to find BD. So what is BD? We can do AD minus AB. A to D is 9.4 and minus 6, AB 6, right? 9.4 minus 6, which is equals to 3.4 centimeter, right? So we got this length 3.4, and this is 6 centimeter. Now we have to find this arc length. For this arc length, we need to find the angle, right? So what is the angle A? Okay, to get the value of angle A, let me apply law of sine here, right? Okay, by using law of sine, sine A over the side A, the front side is 6, equals to sine of 1.8, and its front side is 9.4, right? Let me solve for sine A, which is 6 over 9.4, sine of 1.8. Sine 1.8 radians times by 6 divides 9.4, and doing sine inverse 0.6707. A is 0.6708. Okay, in radians, yes. So we have the angle A. Now to find arc length. Arc length CD, which is radius times theta. Radius of this arc is 9.4. So 9.4 times the theta 0.6708. So times 9.4, which is 6.306 centimeter, right? 6.306. Okay, now let me find the parameter. Parameter of the shaded region is sum of all these three, 6 plus 3.4 plus 6.306. Okay, 6 plus 3.4 plus 6.306, 15.706 or 15.7 centimeter. This is the parameter of the shaded region. Now for part B, find the area of the shaded region. Okay, so this is a shaded region. You can see, to find the area of the shaded region, we have to find the area of this arc, area of the sector of a circle, and then subtract the area of this triangle, right? We will get the shaded area, right? So first we need to find the area of triangle, because this is not shaded, which is half. The two sides are 6 into 6 and sine of the angle is 1.8. Right, let me calculate this. We have sine 1.8 radians times 6 times 6 divided by 2, 17.53. 17.53 centimeter square. Now let me find area of a sector, area of sector of a circle, which is equals to half radius square theta. Radius of a sector is 9.4 and theta is, this is 9.4. Theta is angle A, and we got this angle A, right? Okay, so which is 0.6708 radians, right? Now let me calculate the sector area. 1 by 2 times 9.4 times 9.4, it's square, so times 0.6708, 29.64 29.64 centimeter square, right? Now to find the shaded area, from the sector we have to subtract the triangle, because triangle is not shaded, right? So we can say 29.64 minus 17.53, which is 12.1 centimeter square, is a shaded area. Question number 10, the function f is defined by f of x equals to this for x is greater than minus 1 by 2. Part A, find the integration of the function from 1 to infinity. Okay, so we have to integrate from 1 to infinity the function 4x plus 2, and its power is minus 2 with respect to dx. Okay, so its integration is 4x plus 2 minus 2 plus 1 over minus 2 plus 1, multiply 1 over the derivative of 4x plus 2 is just 4, and the limits are from 1 to infinity, right? So this is minus 1 by 4, 4x plus 2 power is minus 1 from 1 to infinity, right? So we can say minus 1 by 4 into 4x plus 2 from 1 to infinity, right? Now let me substitute the limits. So minus 1 by 4, 4 infinity plus 2 upper limit, plus 1 by 4 for the lower limit, minus times minus would be plus, 4 plus 2. We have 1 here. 4 times infinity is infinity. Infinity plus something is infinity, and product is infinity. 1 over infinity plus 1 over, we have 4 plus 2 is 6, and 6 times 4 is 24. 1 over 24. Something divide infinity is 0. 0 plus 1 over 24. So the simplified answer is just 1 by 24 for this integral, right? Now for the second part, a point is moving along the curve y equals to f of x in such a way that as it passes through point A, its y coordinate is decreasing at a rate of k units per second. So means dy over dt, the derivative of y with respect to time is negative of k, and its x coordinate is increasing at a rate of k units per second. Dx over dt is equals to positive of k, right? Now for part B, find the coordinates of A, right? So we need to find dy over dx. What is dy by dx? So power rule we have to apply. Power, the base function, power minus 1, and the derivative of base function, which is equals to negative 8 over 4x plus 2 whole cube. All right, now we have to apply dy over dx is dy over dt times dt over dx, the chain rule, right? So substituting the values, we know that dy over dx we got is minus 8 over 4x plus 2 whole cube. Dy over dt is negative of k times 1 over k. K is cancelled with k, we are just left with minus 1. So minus 8 over 4x plus 2 whole cube is equals to minus 1, right? So we can cancel the negative sign and doing a cross multiplication. So 8 is a cube of 2, and this is 4x plus 2 whole cube. If I take the cube root on both sides, 2 would be equals to 4x plus 2. So 2 minus 2 divided by 4, which is 0. This is x. So we know that we got the x coordinate of A, which is equals to 0. Now let me solve for the y coordinate. Y is equals to 4x plus 2. Its power is minus 2. So x would be 0. So 2 power minus 2, which is equals to 1 over 4. So we can say the coordinates of point A, x coordinate is 0 and the y coordinate is 1 by 4. Right. Now for question number 11, the point P lies on a line with equation y equals to mx plus c, where m and c are positive constants. So m and c should be positive. A curve has equation y equals to minus m over x there is a single point P on the curve such that this straight line is tangent to the curve at P. So this is basically the equation of tangent of this curve. Now for part A, find the coordinates of P, giving the y coordinate in terms of m. Okay, so to find the coordinates of P, first let me find the equation of tangent. For equation of tangent, we have to find the gradient of this curve, which is minus m, and 1 over x is minus 1 over x square. Derivative, so minus m over, positive m over x square is the derivative. Now let me compare the gradients. Gradient of this curve and gradient of the equation of tangent. So we can say m is a gradient here, and here m over x square. So cross multiplication, x square would be equals to 1. We can cancel the m. So x would be equals to plus minus square root of 1. Or we can say plus minus 1. Right. Okay. So we have two values for x. For x is equals to 1. What is my y value? Y is equals to, you can see x is 1 minus m. For x is minus 1. What is y? Y is x is minus 1, which is plus m. Y is positive m. But we have given the information that m and c should be a positive constant. So we are not considering this value. So we can say the coordinates of P are x coordinate is minus 1 and the y coordinate is m. These are the coordinates for P. The normal to the curve at P intersect the curve again at Q. So basically we have to find the equation of normal to the curve at a point P having coordinates minus 1 and positive m. Right. Find the coordinates of Q in terms of m. Right. So for equation of normal, we have to find the gradient. Right. Dy by dx at x is equals to minus 1. So we have the gradient is m over x square, so which is just m, right? And the gradient of normal is negative reciprocal, so minus 1 over m, right? Now let me write down the equation of normal. Equation of normal at point P, which is minus 1m. So we have y minus y naught is the slope minus 1 over m into x minus x naught, right? Now let me solve for y from here. So what is y? Y equals to minus x over m minus 1 over m and positive m, right? This is the y value, and we have given then from this is the equation of normal, right? So equation of normal intersect the curve again at point Q. So we need to find the point of intersection of normal and curve. Okay, so the equation of normal is minus x over m minus 1 over m plus m, and the equation of curve we have given is minus m over x. Okay, so let me simplify, multiplying both sides by minus x over m, and this is also minus x over m. So this is x square over m square, and here positive x over m square, m is cancelled with m, positive x, and this is just 1, right? Now we have negative x, yes, negative over here, sorry. Now x square over m square plus x over m square minus x minus 1 equals to 0. Now we have to multiply by m square, right? So if I multiply by m square, we have just x square plus x minus m square x minus m square equals to 0, right? So x square plus x coefficients are 1 minus m square, and the constant is minus m square. This would be equals to 0, right? So this look like a quadratic equation in a variable x. So we have to find the roots. Let me apply the quadratic formula over here. So we can say that x is equals to negative of b. The b value is this. So if we do the negative of this, we have m square minus 1, right? Okay, plus minus square root b square. So this term square, which is 1 plus m square minus 2 m, this is m power 4 minus 2m square minus 4ac, minus times 4, a is 1 and the c is this, so positive 4m square. This whole divides 2 times of the a value, which is just 2, right? So x would be equals to m square minus 1, right, plus minus square root m power 4, right, and plus 2m square plus 1 divides 2. Okay, let me simplify this further. Further simplification gives me x is equals to m square minus 1 plus minus square root, this is m square plus 1 whole square divides 2. Cancel the square and the square root, we have m square minus 1 plus minus m square plus 1 divides 2, right? Now we have two values for m. So x would be equals to m square minus 1 plus m square plus 1 divided by 2. We can cancel the 1 plus 1. We have 2m square over 2 2 is cancelled with 2, so x value is m square, right? Let me find the other root. So x would be equals to m square minus 1 with the negative of this. So changing the signs, minus m square minus 1 divided by 2. Positive m square, negative m square is cancelled, minus 2 over 2, which is equals to negative 1. So we are not considering this root because in the question we have given that the coordinates of q should be in terms of m. So x coordinate should be in terms of m. Let me find the y coordinate now, right? So when x is equals to m square, what is y? So y is equals to minus m over x. This is equation of curve, right? So just substitute the value, minus m over x square, sorry, not x square, this is m square. Y is equals to minus m and the x value is m square. So m is cancelled with this m, so minus 1 over m. So we can say the coordinates of q in terms of m. X coordinate is m square and the y coordinate is minus 1 over m. Right. So that was the last question of our paper. If you have any queries, please let me know in the comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.